Hello, this is a video for EDX Statistics 1. It's the first video in this series and it will look at one-tailed tests of the mean of a Poisson distribution. When carrying out a hypothesis test for the mean of a Poisson distribution, we are trying to establish if we have enough evidence to conclude that there has been a change in the mean of the distribution. In this video we're only going to look at one-tailed tests, and that means we are looking for a definite increase or decrease. Here's an example of a scenario that you might want to hypothesis test. An estate agent is concerned that the housing market appears to be slowing down. Records from recent years show that on average he sells 6 houses during the month of October, and this year, in October, he's only sold 2 houses. We want to know if this provides evidence at the 5% level that the mean number of houses has decreased. So when carrying out any hypothesis test, we want to know how likely this result is if the mean hasn't changed. So in this case, we want to know what the probability of being less than or equal to 2 is given the Poisson distribution with a mean of 6. So as with any hypothesis test, we're going to establish the null and alternative hypotheses first. So in this case, our null hypothesis is going to be that lambda is equal to 6, because that is what we've observed previously. And the estate agent is worried that lambda has decreased, so that's going to be our alternative hypothesis, that lambda is less than 6. We're asked in the question to test at the 5% significance level, but we could set this at any level if we weren't asked for a specific one. What we've observed is that in this October only 2 houses have been sold, so our random variable x is equal to 2. And what we want to do is calculate the probability that if lambda is equal to 6, what's the probability of getting less than or equal to 2? You can calculate this with your calculator or with the formula, calculating 0, 1 and 2. And you can see here I've done this with a statistical package on GeoGebra. And I've calculated the value of the probability that x is less than or equal to 2 to be 0.062. We need to compare this to the significance level, which is 0.05. The probability that x is less than or equal to 2 is greater than 0.05, so we can't reject h0. There is not sufficient evidence to suggest that the number of houses sold in October has decreased. Here's another example of the same sort of test. Here you have Karen, who keeps a record of the number of colds she has over the year. And she's found that on average she has 4 colds. She starts a new job and thinks that due to inadequate heating, she gets more colds than usual. In the first year of her new job, she gets 8 colds, and we want to test whether this provides sufficient evidence at the 10% level to suggest that Karen has had more colds than usual. So we want to use a Poisson distribution to model this situation, so we have to assume that the colds are caught randomly. As before, we set up our null and alternative hypotheses, and we're asked to test this at the 10% level. So we use the distribution Poisson with a lambda value of 4, which comes from the null hypotheses, and we've observed that we've caught 8 colds in this winter. So we're looking for the probability that x is greater than or equal to 8, and the reason we're doing greater than or equal to is because our alternative hypothesis is greater than. Calculating that probability on your calculator will give you 0.0511. Now this is less than the significance level of 0.1, 10%. So this means that there is enough evidence to reject h0. There is evidence to suggest that she has caught more colds than usual this year. It's worth noting that if the significance level had been 5%, as in the previous question, there wouldn't have been enough evidence to reject H0, and we would have concluded that there was insufficient evidence to suggest that she'd caught more colds than usual this year. So you can see that the conclusion often depends on how strong the significance level is. That's the end of this video. The next video in this series is looking at two-tailed hypothesis tests of the mean of a Poisson distribution.